let's talk about nodes. So you may hear this term referred to as a node or an element. I prefer node just because that's how I learned it. But you know that those are usually the same, refer to the same idea of one element or node within the larger linked list data structure. So really what a node is it's a class in Java, and thus it is instantiated as an object. And what it does is it essentially contains two things. It contains bits of information, and it contains a reference to the next node in the linked list. So the information can be any number of variables. This is really kind of a vague term intentionally because it is completely up to you what you need or want your information to be. It could be ints, strings, booleans, other objects of other classes. You know, when you get into really big projects, you'll probably have a ton of information in nodes and linked lists. And then no matter what information you have, you always have to have a reference to the next node in the list. And note that this is for singly linked lists. If you have a doubly linked list, then you would have a reference to the next node and the previous node. But in my experience, it's more common to see a singly linked list than a doubly linked list. But just know that that's also something that can happen, in which case you'd have to have two references. Okay, so those are the two main parts of a node. And so now we need to talk about how to actually construct the node. So as with any class in Java, we need to have constructors for that class to tell the compiler how to make an object of that class. So the constructors are a little, you know, you can pick and choose what you want to use. There's not any super, you know, hard, fast rules. But generally, you're going to have some combination of an unparameterized constructor, a parameterized constructor that takes some amount of information as the parameter or parameters. And then you could also have a parameterized constructor that takes in information as well as the next node reference as parameters. So I'll show you what I mean. So up here on the top, we have the class declaration. So we just say public class node or element or whatever you want to call, you know, one section of your linked list. And then we have our data variables. And in this example that I'm going to be showing you, I've just kept it really simple. We just have a string called name. Again, you could have any number of different strings, integers, booleans, different data types, what have you. But we don't need to worry about that right now. Then we also have the next pointer. And I say pointer here. I think I talked about this in a second. Pointers, technically we're talking about references here, object references. I might slip up and say pointer sometime because pointers are basically a really similar aspect of programming languages like Java, C++. They don't actually exist in Java, but their references and pointers are very similar. So in Java, we're always talking about object references, not pointers, but I might slip up and say pointer. Just know that I mean reference. So we have the next reference here, and we just say node next to say that we are always going to have a next reference in any node. All right, so on the left side here, we have our unparameterized constructor. So as you can see, just like any class, any constructor for any class, we're going to say public and then the name of the class. And we're going to set this dot name to you know, an empty string, since we don't know yet what is going to be put into that string, right? Or that the constructor is not giving us any information. And then this dot next is going to point to null or refer to null because, again, we don't have anything to work with. That's the best we can do for right now. But nonetheless, it will still create the node as an object, even if its information is kind of default. And then next we have the info parameter. And it's pretty much the exact same thing as the unparameterized constructor, except that you're passing in any number, as much info as you have in your node as the parameter. So in this example, we are passing in a string called name, and we're assigning this dot name equals to name. And then we're just setting the next pointer or next reference to null because we don't know what it is yet. And then down here on the bottom, we have the parameter, which accepts both information and the next object reference as parameters. And again, kind of following suit, we're setting this dot name equals to name, this dot next equals to next, name and next being the parameters that were passed in. And so now our node, we have the same object node that node object that we've created in the last two, but now we just have that name and that next node reference to fill in. All right, so a little bit of practice. Based on the node constructors that we just talked about, what will be the results of each of these lines? So I'm going to give you a few minutes to go over these and think about what you think is going to be the result of each of these lines. So let's see. There we go. All right, so for the first line here, we are saying node A equals new node, parentheses. And so this works with our parameter list or unparameterized constructor. So a new node is created. The node reference is called A, and the A contains an empty string for the name and an empty reference or the null reference for the next node reference. All right, so 2, we are creating a node reference called B, but we're not actually linking it to any object. There's no dynamic memory being allocated. The actual data structure of the node doesn't exist yet, just basically just something that could refer to the node. So there's no compilation error or anything. It's just we haven't really made a new node yet, just the reference. 3, so this third line here, we have C equals new node, and then in parentheses, name, in quotes. So you might think this looks good as a use of our info parameterized constructor. However, this is actually going to cause a compilation error because there's no type declaration for what C is. We always need type declarations in Java. So you would need to say node C, or else the compiler is not going to know what the heck C is. And since Java is a strongly typed language, this is necessary or else it's going to crash. All right, then number 4, we say node D equals new node, and then we have in quotes sample, comma, and then the letter A. And this makes use of our parameterized constructor with both information and a next object or next node reference. So the name is going to be sample, and the next object reference it's going to be pointing to A, which we created in that first line. All right.